limit x tends to 0, e raised to x minus 1 upon x is 1. So this is a property, and we are going to write a proof of this. Okay, so here we are going to use a definition of e raised to x in the form of, now e raised to x is expressed in different ways. So if I write it like an infinite series, then e raised to x is written as 1 upon x plus x square upon 2 factorial plus x cube upon 3 factorial, and that goes on till infinity. And here we have a minus 1, and then you have a minus 1 over here. So this minus 1 comes over there, and then you can see that this and this will get cancelled. So limit x tends to 0. If I take a x out over here, this is x down. If I take a x out, I'll get 1 plus x upon 2 factorial, x square upon 3 factorial. That goes on till infinite, and this is upon x. So we know that as x tends to 0, x is not equal to 0, so this can be removed. And we have limit x tends to 0, 1 plus x upon 2 factorial plus x square upon 3 factorial. So we get limit x tends to 0, 1, or we take the limit. So you get 1 plus 0 plus 0. And the answer is 1. So this is the proof for this property. Now the same thing can be done using a sandwich theorem. So let me show that. This is mod x plus 1. Okay, so this graph looks like this. And below that, I have mod x plus 1. So you can see that they form a graph which are like reflection of each other. And in this, I'm going to have e raised to x minus 1 upon x. Okay, so you can see this. Now, if I use the sandwich theorem, in that we are going to talk about this area. So what in this area? As x approaches 0. So you can see that if this is f of x, this is g of x, and this is p of x. So they are in the order. And according to the squeeze theorem, if at a point, like say x equal to 0, both the functions, negative mod x plus 1 and mod x plus 1, both will give you 1 as an answer. And therefore, we can say that e raised to x minus 1 upon x also give you 1 as an answer. So this is another proof for the same. Limit x tends to 0, e raised to x minus 1 upon x, the answer is 1. So now we can think of some more properties similar to the one which we have derived here. So if this is a raised to x minus 1 upon x, so you'll get ln of a. There is another definition of e. There is 1 plus x, 1 upon x is equal to e as x becomes smaller and smaller. So here we have limit x tends to 0, 1 plus x upon 1 upon x is e. So let me show that to you over the graph as well. 1 plus x raised to 1 upon x. So when x is 0, this point will be e. Now the same property can be written as, suppose you have limit x tends to 0, log of 1 plus x upon x. So this can be considered like limit x tends to 0, 1 upon x, log 1 plus x, which is limit x tends to 0, log 1 plus x raised to that. You can take the log out and you take the limit inside. So you get log of e. So the answer is 1. So what is the property? Limit x tends to 0, log 1 plus x upon x gives you 1. So we have this property over here. We know this. And now we have this as well. Okay, what else is there? If it is approaching infinity, then 1 plus 1 over x, this is e. Okay, so we can compare it to this. And so over here, the next property is limit x tends to infinity, 1 plus a upon x. So remember, the reciprocal is here. Okay, here also there is a reciprocal. So limit x tends to infinity, 1 plus a upon x, and if I write x upon a, I'll multiply by a. So this is going to give you e, and this a will be e raised to a. So the answer to this is e raised to a. A couple more properties, this one followed by this one. So these were some of the proof to the limit properties. Thank you.